All right, class, this video is going to help with 10.7, which is elasticity of demand, which you should have looked at in economics, or if you haven't done economics yet, you will. I can't remember if I think it's in micro. Maybe macro, I don't remember. All right, either way, you're going to have to watch how I teach you it with calculus. Okay, so first of all, with this one, I want you to take a minute, pause the video, and write down this notes. So the first idea is the relative rate of change of a function. What is this rate of change that's happening with this function? So we can do this with demand or price. And the way that we do it is we do the derivative over the original function. So some of your homework, you'll just be asked, what's the relative rate of change? If you're asked what's the percentage rate of change, it's the same thing. What they do different? You times by 100. So if my relative rate of change is 0.1, what is my percentage rate of change? 10%. So just be careful what they're asking for. Do they want it in decimal form or as a percent? So relative and percent rates of change. What are you doing? You're changing your rate. You're going from one thing to the next. Okay, so let's pause and let's look at an example of this relative rate of change. Oh, I lost my blank paper. It's hiding. Okay, so let's look down here at this problem here. It says we have our function 25x minus 0.4x squared, and it just says, what's your relative rate of change? Well, we know that that means we need to find the derivative of this function and divide that by the original. So what's the derivative? 25x becomes 25. 2 times 0.4 is a 0.8. And then you would drop your x to an x from an x squared. Okay, so 25 minus 0.8x, that's our derivative. Now, to get the rate of change, we take this and we divide by the original. And this is, well, I'm lazy. This is the relative rate of change. I've changed it. There we go. I don't want it to say derivative. I'm just too lazy to rewrite it. That's all right. So there we go. There's our solution. That's it. Derivative divided by original. Now, if I had a price X, or the number of items is typically X, not price. It could be price. It could be price or demand. Anyway, X is typically our number of items sold. So if I wanted to find the change, I could put in a value like maybe I sold 4 items, or X is 4. I could put 4 in here and get that actual rate of change. This is how you get the formula. Then use it by putting in a value that they may give you. Okay, so then for the elasticity of demand, their notes are kind of crappy, so we're going to bounce to my handwritten notes here in a sec. But basically, they say the price and demand are related by X equals this function in terms of price. Then the elasticity of demand, isn't that funny, is equal to negative price times derivative over original. Okay, memorize this one. It will come up on the final, on the next test in economics. So again, you probably learned a little bit different method for this rate. A rate is a function, or basically a slope. We're going to use a derivative. Okay, big idea. And I'm going to switch over to my notes. So we know that the elasticity of demand of a price is this function, negative price times the derivative over original. Where does that come from? It comes from the negative relative rate of change of demand. So your rate of change of demand is derivative over original, divided by the relative rate of change of price. Okay, so demand divided by price. And I believe you do like a slope with that and divide them. I've kind of seen it, but I probably did it 20 years ago when I got my business degree, but I don't remember. Okay, so this is where the formula comes from, which they just didn't show you. Not that you have to know where the formula comes from, but it kind of is cool. Now, What does it mean if I'm inelastic? That means my EFP is between 0 and 1 for however many, or for whatever the price is. So notice it's not an X. X typically refers to the number of items sold, and P is our price. So if my price, point was $10 for something, and my elasticity of demand is between 0 and 1, then that's going to tell me my price will increase. If I increase my price, so will my revenue. So I can go up a little on that price. And guess what? My revenue will go up too. Okay. You are not priced out of this item yet. So if I'm charging $10 for, I don't know, a burger and fries at a restaurant, I could go up a little and still people will purchase it and I'll make more money, right? So the demand is not sensitive to change in price. That is, the percentage change in price produces a smaller percentage change in demand. It's still going to go down in demand, so it's saying a smaller percent. If I raise my burger from $10 to $12, somebody's going to get mad and they're going to say, I don't want this item. But not enough people that I won't make more money. That's what the bottom line is, right? Okay. So for elastic, that is where our EFP, our elasticity of demand, is greater than 1. Then I'm elastic. What does elastic mean? It means if you increase the price, you will decrease your revenue. You are pricing people out of this burger. So if I charge you $20, how many people are still going to want to buy it? I just doubled my price. Not a lot. So you're going to really lose money overall in our revenue, okay? So the demand is sensitive to changes in price. That is, a percentage change in price produces a small percent of change in demand. Oh, sorry, I was like small, large. It's like that's wrong. That is, a percent of change in a price produces a large percent of change in demand. I don't know, read small instead of large. I was like, no. There's our big word change from one to the other. So pause, write that down. Last one, what if it equals 1? Then what we call this is our unit. A percent of change in price produces the same percent of change in demand. This is usually what you're striving for, like your unit price. I haven't priced people out. I'm kind of like right on. Okay, so the change in demand is equal to the EFP times the change in price percent. I don't think you have to use that. I wrote it down, but I don't think we use it. All right, so you can see my next example here. What if I'm given this function in terms of price and it says 10,000 minus 350 times P? Okay, that's my formula for like probably this is my overhead cost and this is how much per of items. Well, I shouldn't say that. Anyway, the formula has some meaning, but this one I randomly just picked from the note sheet. So what we're going to do is we're going to start with finding that EFP. All right, so quite a bit of your homework is finding just this formula, going no further. The formula is negative price times the derivative. Well, 10,000 disappears. And so we're left with negative 350 because the P will also disappear. So I have negative P times the negative 350 over the original. That's it. That's my formula right here. Okay. You're done on quite a few of your homework problems. That's all it's asking. If I said, what if your price is $10? What if your price is $15? Then what am I? Am I elastic, inelastic? This is the formula. Putting in those prices is how you decide whether something's elastic or inelastic. So if I put 10 in, so EFP at $10, then we would put it into the formula here. Okay, and we're going to divide, and I'm going to get 0.54. That means I'm inelastic at $10 for this burger. Oh, I like that it's a burger still. I'm inelastic. Can I go up in price and still raise my revenue? Mm-hmm. Are you still going to lose some demand? Mm-hmm. But you have a lower percent of demand, so therefore your revenue is still going to be higher. I haven't priced people out yet. Okay. What if I'm charging $15? I put that in, I get 1.105. That means I'm elastic, I'm greater than 1. Oof, now I am starting to lose revenue because my demand, there's a bigger change in demand. I am elastic. Okay. So if the price increases by 1%, what happens at these values? So if the price increases at that 1%, what happens? So what I can do is I already have my EFP is 54 cents at the $10. Or so I can times that by the 1% and I get 0.54. So if I go up 1% in price, then I will decrease demand by 0.54. Very little percent. I am decreasing demand by 0.54%. Big idea, mathematically, I take this number times the increase in the price, and it will get me what I decrease by. Always going to decrease in demand. I mean, somebody's going to get mad when you raise your price, right? Here at the $15, I have the 1 times the 1%, which would get me this, which means I decrease demand by $1.11-ish. No, I guess it's a percent, not dollars. 1.105%. So a lot bigger. I'm decreasing demand by 1%. Okay, so overall, this one starts to not be so good. Okay. What if I decide, oh wait, that might be part of this. Is that part of this? No. I'm getting mixed up with my notes and my scratch paper. Okay, this is all still my notes. Okay, what if I have a function and I want to know where is it elastic, where is it inelastic? I just know like I'm charging this much money. I need to know, these are my costs. So for this one, let's say, I don't remember what problem number I'm on. We're going to go back to problem 1 just for fun. The F of P is equal to 900 minus 3P squared. And I want to know, where is this? Inelastic and elastic. Where is it? And all of a sudden my handwriting got really ugly. Oh well. So where are we gonna start? We're gonna start with our E of P. Okay. So what is that again? Negative P, negative price times the derivative. 900 disappears. Negative 3 times 2 is negative 6P. Okay. All divided by the original 900 minus 3P squared. Okay, then from here, I do want to simplify the top because I'm going to use this function kind of a lot. So I do want to simplify the top to be 6P squared over the 900 minus 3P squared. Simplifying, you'll notice, isn't that big of a deal. I can put in a price and get my information. So in my math lab also, it's very generous on what you can put in for your simplified version. Okay, so from here, if I look at elastic, I am going to look at where this is greater than 1. So I have 6P squared over 900 minus 3P squared. Where is this bigger than 1? Okay, so where is this bigger than 1? So what I love is you always have ones or zeros. So this times 1 is 1 itself. So really this will be 6P squared is greater than 900 minus 3P squared. Then from here, I can add my P over here and I get what? 6, 7, 8, 9, p squared is greater than 900. Divide by 9. I get p squared. Where did I mess up? 6. I got a different solution over here. Why? Oh, I was just looking at the wrong spot. Never mind. It is greater than 100. If I take the square root of both sides, p is greater than 10. I don't look at it, the negative 10. Excuse me, I'm going to have to blow my nose. I'm going to take this off for a second. Okay. I'd rather hear you clinking, hear my clinking headset than my nose blow. Okay, so from here, then I have, it's greater than 10. So when my price is greater than 10, I'm elastic. Here's the kicker though. I have a spot where it hits negative, like where I price this thing so high, I'm just going to lose money because I'm still producing and I have overhead costs and stuff like that. The way that I find the top value is the domain. Where is the original function greater than or equal to 0? So 900 minus 3p squared. Where is this greater than or equal to 0? Okay, so I have to solve this. Got a 0 here, so when I minus the 900 over, I get negative 3p squared is greater than or equal to negative 900. Divide by negative 3. And p squared, oh, what happens when I divide by negative? Switch the inequality, okay, is equal to 300. So p is equal, less than or equal to the square root of 300, which is about, nice symbol I made there, 17.32. Domain, have to do it for elastic, because the directions will clearly say where it's greater than 0. So what we'd say for this one is it's from $10 to 17.32. You are elastic between those two values. Okay, if I go higher than 17, I'm in the negative, not so good. Okay, let's look at inelastic. So what did I do for elastic? Greater than 1 and find the domain. Inelastic inelastic is going to be where you're between 0 and 1. So my EP is between 1 and 0. So I like to separate these. So I'm going to have my 6p squared over 900 minus 3p squared. Where is that less than 1? And I'm going to have my 6p squared, 900 minus 3p squared. Where is that greater than 0? So I'm going to separate them for us like this. Okay, then this one, timesing by 1 again. Ooh, that's pretty easy. So 6p squared is less than 900 minus 3p squared. Add that over, I get 6, 7, 8, 9p squared is less than 900. And I get p squared is less than, oh, do you notice something about this? Maybe you are. 9 divided by 900 is 100. Square root is going to give me 10. Oh, well, once I find the middle number, I don't have to do it twice. This is the same process, but your sign's switched. Okay, so we're less than 10. Now let's do this. So 0 times anything is 0. So when I take that denominator up, it's just 0. So I have 0 is less than 6p squared. Divide by 6 into 0, and I get 0. Square root of 0 is 0. So put these together. P has to be greater than 0 and less than 10. In interval notation, you're going from 0 to 10. That's our inelastic, 0 to 10. Okay. I think what I'll do, so there's a couple other, you can watch the videos. It does give a lot of these. Here's one that I am going to show so you can pause, that has a square root and you can see my work. I'm not going to do the whole thing, but I started with domain. Okay. Well, I started with derivative, domain, and then I went to E of P here. Ew, a little bit ugly. Don't simplify a lot. Just leave it ugly. Okay, and then E of P, I simplified this one quite a bit, but you don't, I mean, simplify as much as you can, but because you're going to use this one. Then where is it greater than 1? Where is it less than 1? And then you can look at where the 0 is on that one too. Where is it less than or greater than 0? I don't know if yeah, it is 0. Okay, so the 20 you only get once. Either way. Okay, so the big takeaway, I'm just going to leave that there for a sec and slowly move it up. And if you want to have that example, then it's all yours. So here's my final answers. Your elastic from 20 to this, or these are the same thing. Inelastic from 0 to 20. Okay. Oh, I think that's about all that I want to show you. If the price increase, what is the approximate change in demand? We did that. I think we're good. Okay.